Air-driven systems, piston engines. Pneumatic systems use compressed air as the working fluid. The advantages are there are no return lines, therefore the system is lighter. A storage tank is not required, the Earth's atmosphere is plentiful. Fewer opportunities for leaks, contamination, fire due to lack of return lines. The disadvantages are air is not a lubricant. There's a danger of water droplets freezing at high altitude. High pressure air storage cylinders are a potential explosive hazard. It's difficult to detect leaks in the system, and a system which uses air is more difficult to seal than one using fluid. This is a schematic for a pneumatic system. There's a charging point and safety disc and a relief valve, with shuttle valves which lead to moisture separators and a chemical dryer, and a non-return valve. This passes through a filter, and more non-return valves, or a relief valve, to accumulators and manual isolation valves, and eventually to the services. For example, passenger door, normal gear, nose wheel steering, and the prop brake. There's also an emergency system, which can be supplied in this means, and a system directly operating the brakes, for example. Active system components. The compressor is engine driven. It provides compressed air for the system operation. It may be piston, rotary screw, or of the vane type. High pressure relief valve. This is fitted as an independent safety device and is not used as the normal means of controlling system pressure. It operates to relieve excess pressure which may result from the failure of other components. The chemical dryer, also known as a dehydrator, removes moisture from the air as it passes through it. The moisture separator is an oil and water trap. It removes oil and water from the air. Pressure regulating valve controls pressure by diverting air to the atmosphere when the air bottle is fully charged. The air bottle stores compressed air for use in the system. It's typically made of fiberglass, light alloy, or steel. Ground charging valve enables pneumatic system to be charged with air when the aircraft is on the ground. The pipes. Metal piping is generally used even though rubber reinforced with wire may be used. Pressure indicator shows pressure in the system. The pressure reducing valve is fitted where normal system pressure must be reduced to ensure efficient operation of a subsystem. The air filter is usually fitted immediately after the air bottle. It prevents oil, vapour, dirt, moisture from passing to downstream services. Pressure maintaining valve conserves air pressure for operation of essential services in the event of low pressure or system pressure failure. The control valve routes air to the correct side of a service actuator. The isolation valve is used for ground maintenance and removes the need to depressurize the complete system when working on a part of it. Miscellaneous. The storage bottle provides compressed air to operate all services. The compressor builds up system pressure when it falls below a nominal level. Pneumatic power can be used to operate items such as the landing gear on the F4 Phantom, brakes on the MiG-29, flaps on the F4 Phantom, or rudder boost on the Beech 200. In low pressure systems, the working pressure is approximately 450 psi. In high pressure systems, the working pressure is approximately 3000 psi. Additional uses for pneumatic systems include air conditioning and pressurization, low pressure air for gyroscopic instruments, thermal anti-icing, engine starting, and pressurization of reservoirs and water tanks.